we're going to talk about Math 105, Section 1.2, the rate of change. And when we discuss this idea of rate of change, I think we should start out with just some vocabulary. When I think about a rate, I think we can certainly talk about miles per hour, but really a rate is any quantity divided by any other quantity. I could talk about some number of apples I eat per miles that I ride on my horse. Or I could talk about how many furlongs I travel given a fortnight. Rate is just going to be some quantity divided by some other. Change is something else. Change usually implies subtraction. When I think about how much money I get back from a store, I'm going to be subtracting from that to get my change. When I say, hey, how much did my weight grow, or what was my change in weight, I'm going to take my new weight, I'm going to subtract my old, and I'm going to get my change. Also described with this symbol, delta. That's a capital delta. Okay, so our rate of change is going to describe some change of one quantity divided by some change in some other quantity. So we can say that it's going to be the change in output divided by the change in input. Now, from back in the day, your output variable was always y. I don't really care for y. I'm going to say, we'll say delta q over delta t. And maybe I'll even go q2 minus q1. That's quantity 2 minus quantity 1 divided by time 2 minus time 1. But if I really wanted to, I could also say that this is completely equivalent to y2 minus y1 over x2 minus x1, which is your old formula for your friend, slope. So when I think about the rate of change or the average rate of change, which I'm going to be abbreviating as the AROC, when I talk about this, all I'm dealing with is really this slope idea. So suppose I go to Las Vegas and I make a graph of how much money I've earned versus the number of hours that I've been playing at the casino. And I don't really care about different points here. But so from time equals 0, certainly, and let's call that maybe 3. Over the first 3 hours, and you know what, I'm going to put some numbers here. Let's say we were at 200, and here, how about 160? So from hour 0 to hour 3, my money went up by $40. So what was the average rate of change over that time period? Well, I can say that the change in dollars here was 40. 200 minus 160 over the change in time. And we're done. We have 40 over $3 per hour, which is approximately $33 per hour. Now, the way that we can look at this is we can say, well, I'm going from this point, which is 0, 160, to that point, which is 3, 200, and this dashed line is that where the slope is $13.3 per hour. Let's suppose that after 4 hours, we got back to 160. I'm looking for the average rate of change from 0 to 4 hours. And now we're looking at 160, this point, minus 160, my starting point, over 4 minus 0. Well, that's going to be 0 divided by 4. That's going to be 0. That means we earned, on average, $0 for each hour that we played, from 0 to 4 hours of play at the casino. Let's do one more for ourselves. Let's go from this point to this point. 3 to 4. Because here, our previous average rate of change was represented by this horizontal line. Now, I want one represented by this line right here. So what happened? Well, we have the point 4, 160 and the point 3, 200. So we can do 160 minus 200 over 4 minus 3 dollars per hour. So, as much as I love all of these things, it's super important to be able to interpret them. And that's what's coming next. So when we talk about average rate of change interpretations, there are 4 things that every good interpretation must have. And for example, when we talked about the average rate of change from 3 to 4, it was equal to negative $40 per hour. And that was from the previous problem. But so the first thing that the average rate of change has to have is we have to use the word average. As in, on average, the next thing that we need to include here is we have to talk about units. If I'm not talking about dollars and hours, I'm going to be in a world of hurt. The third thing that we have to discuss here is increasing or decreasing. Certainly, our dollars decreased. And so, depending on the problem and the context, we're going to talk about it being increasing or decreasing. And then, finally, we have to talk about the domain or endpoints. So, on average here, what went down? From 3 hours to 4 hours at the casino, my money decreased by $40 each hour. So I want you to notice that I'm using each here. I'm not using per. I'm trying to make this as non-mathy as possible. Okay, let's do one last example together. Okay, let's let P of D be the fluid ounces of drink I consume after eating D grams of popcorn at a movie. Certainly I can get a rate here by dividing the output, which is ounces of drink, by the input, which is grams of popcorn. And suppose that the average rate of change from 10 to 50 is 1.6. Now, 10 and 50, these are both grams of popcorn. And 1.6 is the average rate of change. And so what's the unit here going to be? Well, it's got to be the unit of the output, which is fluid ounces of drink, divided by grams of popcorn. Okay, let's interpret it. When I eat from 10 to 50 grams of popcorn at a movie, and already, look what I've done. I've taken care of my domain and my endpoints, right? When I eat from 10 to 50 grams of popcorn at a movie, my drink consumption increases, yes, by 1.6 fluid ounces for each gram on average. So when I say 1.6 fluid ounces for each gram, I could probably say of popcorn. But that takes care of my units. And then I can sneak on average in there. Here's the thing. The more practice you get here, the better you're going to get at it. And, you can take these 4 things and kind of scuggle them up as you see fit, okay?